Hi students, in this video I'll be going through the 2022 O-Level Additional Mathematics Paper 1 question 13. Alright, so this is the last question in the paper 1. Let's read the question. So a diagram shows part of the curve y equals to 4x plus 2 over x plus 1 for x greater than negative 1. So explain why the curve does not have a stationary point. Okay, so we know very well that at the stationary point, dy dx will be equals to 0. Okay, so since they want us to explain why it does not have a stationary point, we should try to angle our answer such that we can show that dy dx will not be equals to 0, okay, or will never be equals to 0. Okay, so what we are going to do now is we will need to differentiate this expression for y and then obtain dy dx and then try to show that it's not going to be equals to 0, right? Alright, so let's go ahead and differentiate. Okay, so we are going to use the quotient rule to differentiate this expression for y. So dy over dx will be equals to, okay, so over here we have the top term, we call it u, and then bottom term we will call it v. Okay, so for the quotient rule, we will actually differentiate u first, and then we will just leave v untouched, right? So when you differentiate u, you will actually get a 4. Okay, then we will just take the v. Okay, then it's always minus. Okay, so now we will leave the u. So 4x plus 2, and then we will differentiate v. Differentiating x plus 1 just give us 1. Okay, so basically this is what we are going to get. Okay, then it will be over x plus 1 squared. Okay, so let's simplify the top a bit. So we'll get 4x plus 4 minus 4x minus 2, right, over x plus 1 square. Okay, so this will actually leave us with a 2 over x plus 1 squared. Okay, so our job now will be to try to explain why this x plus 1 square can never be equals to 0. Okay, because if it will be equal to 0 means there will be a stationary point. Okay, so let's try to show, okay, that dy dx can never be equal to 0. Okay, so the way to show this we will always start by looking at this square term, right? So remember now x is greater than negative 1. Okay, so let's do it. So for x greater than negative 1, okay, x plus 1 square. Okay, so you just imagine you sub a number that is greater than negative 1 inside this. So a number that is greater than negative 1 will be negative 0.5, 0, or 1, or any other positive number. So no matter which one you sub in, you will realize that x plus 1 square will always be greater than 0. Okay, so now if you look at the dy dx expression, you are taking 2 divided by a number that is greater than 0. 2 divided by a number that is always positive. Okay, so obviously you are going to get a result that is also always positive, right? So what you can say is that so dy over dx, which is equals to 2 over x plus 1 square, will also be equals greater than 0. Okay, so now we have already shown it already. We just need to write a sentence to conclude our answer. So what we can say is that for a curve, to have a stationary point, dy dx must be equals to 0, right? Okay, but for this curve, dy dx is always positive, okay, always greater than 0. So it has no stationary point. Okay, so this is how we will angle our answer. Okay, so basically we find the expression for dy dx and then we try to show that it will never be equal to 0 and hence there will be no stationary point, right? Right, so let's take a look at part B of the question. Okay, so in part B, it says that the point P lies on the curve. Okay, so point P is over here, and the gradient of the curve at P is half. Okay, so basically what they are saying, gradient of the curve at P is half means if you were to draw a tangent, okay, over here, okay, the gradient of this tangent is going to be equals to half, right? Okay, the normal to the curve at P meets the x-axis at A. Okay, so this line AB is actually a normal to the curve at P. Okay, we'll meet the x-axis at point A and the y-axis at point B. They want us to find the area of this triangle. Okay, so this is actually and triangle AOB is actually a right angle triangle. Okay, so to find its area, we can actually find quite easily if we know the length OA and the length OB. And to find the length OA and OB, we will actually need to know the coordinates of B first, right? Okay, so our objective now will be to find the coordinates of B as well as A, and then we should be able to find the area of the triangle quite easily. All right, so in order to find the area of the point coordinates of point A and B, what we can do is we can try to find the equation of the tangent, okay, or the line AB, and then after that, once we have the equation of the line AB, we'll be able to find the coordinates of A and B easily. Because A is on the x-axis, so the y coordinate of A is 0. B is on the y-axis, so the x coordinate of B is 0. Okay, so let's now try to find the equation of the line AB. Right, so if you recall, to find the equation of any line, you need two things. Firstly, you need to know the gradient of the line. Okay, the gradient on line we can find actually very easily because we know the gradient of the tangent. So gradient of tangent times gradient of normal will give us -1. Okay, so maybe we can actually try to find the gradient of the normal, or in other words, gradient of line AB now. Okay, so gradient of AB times the gradient of the tangent at P, right, would be equals to -1. Okay, so the gradient of tangent at P is half, right? So now we can find the gradient of AB times half equals to -1. So the gradient of AB will be equals to -2. Okay, so we know the gradient already. Okay, so the other thing to find the equation on line AB, we need to know the coordinates of point P, okay, or any other point that passes through that line. Okay, so how can we find the coordinates of point P? Right, so if you recall, a gradient of tangent at any point is actually dy dx. Okay, so remember we have already found dy dx in part A, right? So what we can do is we can equate dy dx to half, and then we solve for x, and we will get x coordinate of P. Okay, then we'll just take the x coordinate of P, put inside the equation of the curve, and we'll get the y coordinate. Okay, so that's basically what we're going to do. Right, so what we can do is, so we know gradient of tangent is half, so that means dy dx at P will be equals to half. Okay, so the expression for dy dx is 2 over x plus 1 square, right? So we're going to equate it over here. So x plus 1 square is going to be equals to 4. Okay, so this means that x plus 1 is either, okay, so either x plus 1 equals to -2, so x will be -3, or x plus 1 is equals to 2, so x equals to 1. Okay, so if you can see from this question, the x coordinate of P should be 1 because P is on the positive side of the x-axis, right? Okay, so in other words, we will actually reject this answer, okay, and then we will take x equals to 1. Okay, so when x is equals to 1, sub this one inside the equation of the curve. So 4 times 1 plus 2 over 1 plus 1. So you get 6 over 2, so you actually get y equals to 3. Okay, so in other words, we have found the coordinates of P to be 1, 3. Okay, okay, so now we know the coordinate of the point. Okay, we also know the gradient of the normal, okay, which is -2. So we will be able to find the equation of the normal already. Okay, so let's find the equation of normal, or equation of line AB. Okay, so y minus y1 equals to gradient, which is -2x minus x1 minus 2x plus 2 plus 5. Okay, so we'll get that. Okay, so now we can go ahead and find the coordinates of A and B, and then we will be able to find the area very easily. Okay, so let's continue over here. Okay, so at A, y is equals to 0. So negative 2x plus 5 is 0. So x will be 2.5. Okay, so coordinates of A will be 2.50. Okay. Okay, then at B, x will now be 0. So if x equals to 0, so remember the equation is over here. Okay, so negative 2 times 0 plus 5, so y will be 5. Okay, so the coordinates of B will be 0, 5. So this point is 5. This point is 2.5. Okay, so now we will be able to find the area of B. So that's fine. So area of triangle AOB will be half times the base. Okay, 2.5 times the height, 5. Right, so this will give us 6.25 units square. Right, so overall, still not too difficult of a question. So actually, a good question regarding tangents and normals. Okay, so you should be able to solve it if you know the concept well. Okay, this one is 1, 3. Okay, so let's do the last part of the question. Right, so this is a question which involves multiple concepts coming from different chapters. Like for example, first question regarding stationary point, second one regarding tangents and normals, and now third one regarding sort of like intersection between a line and a curve. All right. Okay, so the line y equals to c does not intersect the curve. By expressing 4x plus 2 over x plus 1 in the form of a plus b over x plus 1, where a, b, and c are constants, explain why c is greater or equals to 4. Okay, so if you recall the line y equals to c, right, it's actually a horizontal line. Okay, so now they are saying that why must the c be greater or equals to 4 such that the horizontal line does not intersect the curve. Okay, so just imagine there's a horizontal line over here. Okay. Okay, so that means they are saying this y equals to c. Why must this c, right, be greater or equal to 4 such that the line will not intersect the curve? Okay, so in other words, if c is less than 4, it will intersect. So if you think about it, basically what they are trying to ask you to show is that they are asking you to show why this maximum point, or rather why the curve, right, okay, the y value of the curve can never be 4 or greater. Okay, because if it's 4 or greater, then it will intersect the line y equals to c. Okay, but anyway, they give you a clue by expressing this in this form. So what we can do is we need to do long division first, right? So let's do long division. So 4x plus 2 divided by x plus 1. So 4. So minus 4x plus 4. Okay, so over here you will get negative 2, alright? Okay, so in other words, 4x plus 2 over x plus 1 is equals to 4 minus 2 over x plus 1. Okay, so we have done the first part of the question. Okay, so now we need to explain why this one, why this one is always less than 4. Okay, because if it's always less than 4, then it will not intersect the line y equals to c, where c is greater or equals to 4. Okay, so let's try to explain for x greater than negative 1. Okay, we always start off by looking at this part. Okay, if x is greater than negative 1, then x plus 1 will be greater than negative 1 plus 1. Okay, so basically I just add 1 here, plus 1 here, then plus 1 here. Alright, so x plus 1 will be greater than 0. Okay, so in other words, x plus 1 will be positive. Alright, so if x plus 1 is positive, then 2 over x plus 1 will also be positive. Okay, so now you think about this. Okay, this part I need to think carefully. So this part, we have already shown that it's going to be positive, right? So 4 minus a positive number. Okay, so if 4 minus a positive number, what do you think will happen to it? It will be less than 4, right? You are taking 4 minus a positive number. The result is definitely going to be less than 4, alright? So we have shown already. Okay, because this is the y, right? Okay, we express this is the equation of the curve, right? Then we express it in this form. Okay, so this is actually the y. Okay, so in other words, the y will be less than 4. So meaning that the curve, okay, no matter what value of x you sub inside, right, okay, is going to be less than 4. Okay, it's going to be lower than 4. So since it's going to be lower than 4, it's never going to intersect the line y equals to c, where c is 4 or greater. Okay, so let's write one concluding statement. So for x greater than -1, the curve is always less than 4. Okay, so y equals to c, okay, will not intersect the curve for c greater or equals to 4. Right, so this is basically how we're going to explain. Okay, we explain why the curve will always be less than 4. Okay, so when I talk about the curve, I'm talking about the y value of the curve. Okay, it's always less than 4. Okay, so it will not intersect the curve. Okay, not intersect. Yeah, so y equals to c, the line will not intersect the curve for c greater or equal to 4. Right, so this is a question, a long question, okay, that involves multiple concepts. Right, so but you should be confident. It's overall not too difficult of a question, right? So you should be confident in solving questions like